Okay, so we're substituting in these values. I'm just going to fill them in. Hang on. Okay, so they're the values. You're then going to plot them. So -2, -3. About there. -1, 1. 0, -1, 1, -3, 2, 1, and 3, 17. Alright, so we join them up. Okay, done. By drawing a suitable straight line graph, find an estimate for the solution of this. Alright, so it was trickier than the previous ones. So x cubed minus 3x minus 1 is the thing we've got. X cubed minus 3x minus 1 is the graph that we've drawn. So what we have to do is say, well, how does this differ to it? So this is x3 minus 3x minus 1 minus another 5. Okay, so because they've got -6 here, it's that graph, but another 5 subtracted from it. So in other words, if this was equal to 0, then it would be, x cubed minus 3x minus 1 equals 5. We're trying to see where that graph is equal to 5. So what we do is draw a horizontal line. At 5, read off a value here, which mine isn't awesome, but I'd say that was probably 2.3, and that was an acceptable solution. It was between 2.2 and 2.5. Okay. And function f is defined as this, find f8, so you're just sticking 8 into there. So it's 2/2, which is 1. Find the inverse function. So we write y equals x minus 6/2. Switch your x and y. So that's 2x equals y minus 6. 2x plus 6 equals y. Which cannot be included in the domain. So we know that the domain, so the values of that go into this expression here have to be greater than or equal to 0. So in other words, to be excluded, it means that x has to be less than 4. Okay, because x minus 4 has to be greater than or equal to 0, so x has to be greater than or equal to 4. So in other words, less than 4 has to be excluded. Express gfx. gf. Alright, so we've got okay, so x minus 6/2. So f is going into g, so we've got the square root of x minus 6/2 subtract 4. Now, but it does say here as simply as possible. So it means we need to rewrite this in a simplified version. So we've got a denominator of 1 currently, and that's a denominator of 2. So we've got x minus 6/2 subtract 8/2. So then we've got -6 subtract 8, which is -14/2. Done. Oh, completely change the values. I'm just going to copy these. You can -3 and 0. Okay, we need to plot them. So -4, 5. Oh gosh, gosh, this really isn't, it's quite hard to see on the screen. Negative 3 is 0. Negative 2 is negative 3. Negative 1 is negative 4. 0, negative 3. 1, 0, and 2, 5. Alright, so I'm going to join them up. We can see it's a parabola. Oops, there we go. Done. So f of 6, so we've got a half multiplied by 6 plus 4. Half of 6 is 3, plus 4 is 7. Work out fg minus 3. So the easiest thing to do here is to work out g of minus 3. So it's negative 6. Negative 3 plus 1 is negative 2, and that is 3. Okay, oh, Miss Harrison, you haven't finished. So that's just g. And then you're going to find f, which is 3. And then you're going to find f of 3. What was f? Half x plus 4. So half of 3 is 1.5. Plus 4 is 5.5, which is, well, you can write 11 over 2, or 5.5, whatever you want to write, any equivalent. Alright, GA equals negative 2, work out the value of A. So that's saying that the function of G is equal to negative 2. 2x equals negative 2. Alright, so 2a plus a plus negative 2, so we're rearranging this. So 2a equals negative 2 lots of a plus 1. So bringing my a's together, I'm adding 2a to both sides, so it's 4a equals negative 2. A is negative 2 over 4, which is negative 1/2. Express the inverse function of f. So what was f? F is a half x plus 4. So x equals a half y plus 4. So a half y is also can be written as y over 2. I've talked about it more than a few times, so it's easy to think of it as that. So it's x minus 4 equals y over 2, and then 2 lots of that. So it's 2 bracket x minus 4, or if you'd expanded that, that's also fine, obviously. Okay, so f of 1, so it's 3 over 4 plus 1, so it's 3 over 5, it's just 3/5, say which must be excluded, so we know that 4 plus x has to be greater than or equal to 0. Oh no, it cannot. It must be greater than 0. Seriously. What am I doing? Becoming negative. So just shush now. So 4 plus x cannot equal 0. Which means x cannot equal negative. Oh, not 14. Aha. So negative 4 is the answer. Oh my gosh, that took a really long time. Right, given that g of a is 7, so that means that 5 plus a is 7, a would be 2. Calculate fg1. So we're going to find g1 first, and then f of 6. 3 plus 4 over 6. 3 over over 10. Find f, g, x. Okay, so g is going into f, g, g, and f is, so it's 3 over 4 plus 5 plus g, plus x. So that's 3 over 9 plus x. Okay. State which value cannot be included in the domain f or g. So x cannot be 0. So solve f a. Okay. All right. So this time it's a composite function. So I would suggest putting them actually together. So f goes into g. Equals. Oh, perhaps I should change these to a's. Sorry. 2 over a plus 1 over 2 over a equals 3. Oh, there's not lots of room here. So 2 over a plus 1 equals 3 multiplied by 2 over a. So 2 over a plus 1 equals 6 over a. I'm going to join my a's together. So I've got 1 equals 6 over a minus 2 over a. So that's 1 equals 4 over a. And then switch these, so a is 4 over 1, which is 4. Express the inverse function. Did I go too fast on that? Okay, so I multiply this up here to get here. Because it's 3 over 1, I did top times top, bottom times bottom, so I got 6 over a. If I've got 2 over a and 6 over a on this side, then I can join them together by subtracting 2 over a from both sides. I have my same denominator, so that rule follows. So I've just got 6 over a, subtract 2 over a, which is 4 over a. And then if your unknown's on the bottom, you can just switch it with the term on the other side. So it's 4 over 1, which is a. Alright, inverse function of g, x plus 1 over x. So then we're going to switch, and you have to switch both x's for the y's. So we've got xy equals y plus 1. Remember, join the x's and y's together. I'm sorry, the y's together. And then factorize. And there's your answer there. Alright, if this is fx, then minus fx is a reflection in the x-axis, so it would be, down here. That's not very well drawn. You draw it beautifully. Okay, so this is where my original vertex was, and it's moved to here. It means it's gone 1, 2, 3, 4, 5, 6 places to the right, which means that it's f of x minus 6. Okay. Here's some graphs. So it's sine graph. To be honest, peeps, the easiest way is to just plug all of these into your graphical calculator and see what they look like. You really need to get into the habit of using the graphical calculator for what it's meant for. But anyway, here this would be our sine graph because it makes the S going through the y-axis. So that would be C. I've told you about x cubed graphs. They either do this, this, or this and this. In other words, it has to be f. 2 to the power x and 4 over x. So 2 to the power x, as your x is increasing, your power is increasing. So that must mean that it's getting bigger and bigger quite quickly. So it would be a. I don't know how else to suggest that. And 4 over x, we talked about those where the x is on the bottom. It's got two quadrants, so it's either like this or like this. And if the value on the top is positive, it's going to be this one. So the only one that looks like that is h. On the grid sketch, f x minus 1, so if it's x minus 1, let's move to the right one. So everything is going to the right one. Fx has a turning point at negative 1, 1. Write down the coordinates of f minus 2. Okay, so if it's a minus in the bracket, it means it's been reflected in the y-axis. So this is our original coordinate. So if it's been reflected in the y-axis, it would be here currently. Let's use a. Okay. But then it's also moved up by 2, so it's 1 up to here. So that's now the coordinate 1, 3. Alright, here's a sine curve, write the coordinates of P. So that is the coordinates. So ideally you're supposed to learn these 90, 180, 270, 360. So that's the coordinate 180, 0. And Q would be 270, negative 1, because it's down here. The A value here tells us about the amplitude. So if it's gone from 3 to negative 1, halfway would be here. And that measurement here is 2. B, the easiest way to do it is to say, well, how many cycles does it do in 360 degrees? So it's done 1, 2, 3 cycles. And then C tells us has it shifted up or down. And as I just said, this is now the new central line. So it's gone up by 1. Okay, so filled in the values 1, 5, 21, and draw those in part of the thing. And use a graph to find an estimate of this solution. Okay, so what's this graph? X cubed minus 3x plus 5. Alright, so when it is equal to 0, it's down here. So that's going to be the value of negative 1.1. By drawing suitable line. Okay, so this is the graph that we've got. Again, this is the graph we're looking for. We need to see what the difference is. So this is x cubed minus 3x squared plus 5. How do we get to this? We would have to add on 2x and take away 1. Okay, so this is the graph we've got from up above. How do we end up with this? We'd have this original function plus 2x minus 1. Okay, so then if that's equal to 0, then we would have it equal to negative 2x plus 1. So this is the line that we need to draw. So we know it goes through positive 1. Oh dear. Positive 1 and has a gradient of negative 2. So we go down 2 units and across 1 unit, down 2 units. And across 1 unit, something like that. Oh gosh, that's not good. And where do they meet? Here at negative 0.8 apparently. Yeah, so that's pretty good. Okay. Oops. last one, find the estimates for this. Okay, eek. Okay, where is it equal to -5? So that's here, so that's -3.4. And draw a suitable line to find solutions of this equation. Okay, so again, the difference would be our original function minus 9x plus 7, and so we would have to add on 5x, and that's all we'd have to add on. So this is the graph we're gonna draw the line y equals -5x. So it goes through 0, has a gradient of -5, so down 5 across 1, down 5 across 1. Oh gosh, that's really badly done. And, oh, worked out quite well though. Where do they meet? At -2.5. Okay, there we're done.